Hey guys, we're on Unit 6. This is day 2. This is properties of parallelograms, which will be our next quadrilateral that we study. And in the warm-up, it says that CDEF is a trapezoid. So we're going to draw one. It does not say that it's isosceles, so we're going to try to make it not look isosceles so we don't think it has properties that it doesn't have. We have to be careful when it tells us what two sides are parallel. So remember that the bases are the ones that are parallel, and they want us to name it CD is one of the bases, but we also have to remember that the name of the trapezoid is CDEF, and since we already have C and D, our E has to go right in order and be here. And then F would have to be here. So that CD is parallel to FE, and we have CDEF going around in a clockwise manner. Okay. It also tells us that if angle F and angle C are in the ratio of 1 to 4, so F will get the 1x and C will get the 4x since they came in that order. So in angle F, we'll put a 1x, or just an x, doesn't matter. And in angle C, we'll put a 4x. All right, and they want us to find the measure of angle F. So we have to solve for x, and we have to remember that in a trapezoid, since these are parallel, they are being cut by this side, looking like it's transversal. And the 4x and the 1x would be what they call same side interior angles. And same side interior angles are supplementary. And so we're going to take our 1x, add our 4x to it, and set it equal to 180 degrees. And we're going to end up with 5x equals 180. And when we divide by 5, we end up with x equals 36. Now they want to know angle F. So when we go back to the picture and we look at angle F as 1x, 1 times 36 is 36. And so we can now say that angle F equals 36 degrees. Done. All right, in a parallelogram is like a trapezoid. In fact, it is a trapezoid, but it has two pairs of opposite sides parallel. So not only are the top and the bottom parallel to each other, but unlike a trapezoid, these two are also parallel. Okay, so a trapezoid has to have at least one, a parallelogram has to have two. Okay? And so that's why a parallelogram is still a trapezoid, because it still has at least one pair of parallel. But because it gains a second pair of parallel, it gains a few more other properties as well. Okay? So right off the bat, it has two pairs of opposite sides parallel. It also has two pairs of opposite sides congruent. So not only is this side parallel to this side, it also has the same length as it, as well as the left side and the right side, so we can tick mark them. Okay. We also have that opposite angles are congruent. So if I take the measure of this angle here, it's going to have the same measure as this angle here, since those are opposite angles. Also, this is an opposite angle of this, and so those are also equal, okay? But not all four are equal. It also has consecutive angles, are supplementary. So kind of like our warm-up, except because it has two pairs of parallel sides, every single set of consecutive angles will be supplementary. So these two will equal 180 degrees. These two angles here will equal 180 degrees. These two angles here are consecutive and will equal 180 degrees. And these two angles here are consecutive and will equal 180 degrees. Okay, last one, the diagonals bisect each other. What that means is when I draw the diagonals in, there's one. Here's the second one. Those two diagonals are different lengths. okay, in a parallelogram. However, they cut each other in half. And so right here is the midpoint of each diagonal. All right. This piece of the diagonal here is going to be equal to this one here, since that green dot is a midpoint of both diagonals. And this part of the diagonal here is going to be equal to this part of the diagonal here, since that green dot is also the midpoint of that diagonal. The diagonals bisect each other. They cut each other in half. All right, and that's what a parallelogram looks like. And so they're going to ask us a bunch of different questions about those properties, and we have to remember the properties so we can set up the equation and we can solve the problem successfully. All right, let's take a look at what they have in number 1. It says in parallelogram ABCD, so we're going to have to draw one. I always draw my parallelograms the same way. They always slant to the right for some reason, but parallelograms can slant to the left. They can slant whichever way. And when I label my parallelogram, usually A is in the bottom left-hand corner, then B, then C, then D goes around clockwise. They tell us at angle D is 6x plus 40, and that angle B is 4x plus 70. And they want us to find the value of x. And so we have to realize that these two angles are opposite angles and that opposite angles are congruent. They have the same exact measure. Therefore, we can take 4x plus 70 and set it equal to 6x plus 40. And we're going to find the value of x that makes those two angles equal. So I'm going to go ahead and subtract 4x. We end up with 70 is equal to 2x plus 40. Go ahead and subtract the 40. And we're going to end up with 30 equals 2x and divide by 2. And x comes out to equal 15. And that is all they wanted us to figure out was the value of x. And so that's our answer. Okay. In number 2, we again have a parallelogram called ABCD. And they tell us the diagonal AC is drawn. And they tell us that the measure of angle D is 110. And that the measure of angle C to A to D, C to A to D, this angle here is 50. And they want us to find the measure of angle CAB, C to A to B. They want to know this one. So if you remember that these are consecutive angles and that they will equal 180 degrees, we could go ahead and figure out how big angle A has to be. If we take 180 degrees and take away the 110, we have 70 degrees for all of angle A. However, part of angle A is already 50. So we can subtract and we end up with 20 degrees left for angle CAB. Okay, there's a couple other ways you can solve that question too. Some people will realize that they have a triangle here with 50 and 110, and that there's only 20 degrees left for this angle up here. And then they're going to realize that Z shape with the parallel lines cut by a transversal, that 20 and this angle here that we were asked to find are alternate interior angles, and we could put the 20 there. So different ways will get you the same answer. In number 3, we have another parallelogram called ABCD. And it says that the measures of angle A and B are in the ratio of 1 to 8, kind of like our warm-up. So therefore, angle A comes first, so it gets the 1x. Angle B comes second, so it gets the 8x. And we're going to use the same property that we just did in the last one, is that these are called consecutive angles, and they're going to add up to equal 180 degrees, just like in our warm-up. And so we got 1x plus 8x equal to 180 degrees. That's 9x equals 180 degrees divide by 9, and x comes out to equal 20. But they want to know how big angle B is. And if you look, angle B has the 8x in it. And so angle B will be 8 times 20. So angle B is equal to 160 degrees. Okay. Last one on this page. In parallelogram QRST, so we'll draw a parallelogram. We'll call it QRST. And it tells us that diagonals QS and RT intersect. So QS is one diagonal, intersects RT, our second diagonal, and they intersect at point E. Then they tell us that QE is 4x plus 3, and that ES is 23. And if you remember from our properties up above, that E right here in a parallelogram is a midpoint. And so this piece of the diagonal will be equal to this piece. And so we could take 4x plus 3 and set it equal to 23. Those two lengths, QE and ES, should be equal in a parallelogram. If we subtract 3, we'll get 20. And if we divide by 4, x is going to come out to equal 5. And that's all they wanted to know, was find the value of x. Done. Okay. All right, I'll see you guys on the back side of notes.